Okay, we're looking at the normal curve here, and this says standard deviation is 19.2. Okay, well, what does standard deviation mean? Let's save this. So let's say I had the numbers 4, 6, 4, -6. Okay, I'm going to go back a little bit. Let's say I had 8, 12, 11, 7, 10, 10, and 9. What is the average of those numbers? So to find the average, 8 plus, get out of the way, 12 plus 11 plus 7 plus 10 plus 10 plus 9 divided by, how many are there? 7? Let's do one more just for fun. 13. So plus 13 and divided by 8, and I get 10. What does 10 tell me? If I were handing out Skittles and everybody got the same amount, everybody would get 10. Did everybody get 10? No. Did everybody get about 10? I would say so. All of those numbers are pretty close to 10, right? Everybody got roughly 10. All right? Well, sometimes when you add numbers up, you get a value that doesn't really make sense. So let's say I had 4, -6, 3, 1, 1, -5. We'll try that, see what happens. Let's find the average here. So 4 -6 plus 3 plus 1 plus 1 minus 5 is -2 divided by 6. And I get -1/3. So let's say this is how much money I owe you and you owe me. Some of you, I owe $6 and $5, and some of you owe me $4 or $3 or $1 or $1. So in this case, the average is -1/3, which means on average, everybody owes me 33 cents. Does that accurately describe what's going on here? No. So we want a way to, let's say we don't really care which way the money is moving. How much is owed in either direction? So we could just get rid of the negatives and then find the average. Oh. So we would go here and then just change the negatives to positives. And then divide that by 6. And I could tell you, all right, on average, about $3.33 is owed in one direction or another. That better describes the information a little bit, right? Well, in statistics, instead of just changing the negatives to positive, we use another method. And this is going to be kind of weird. And just trust me, there's a reason why we do this. And it took me forever to figure out what the reason was. But can you think of another calculation that gets rid of negatives and does not affect positives? What calculation is there that preserves positives and turns negative numbers positives? Squaring it. So let's just go through and square everything. Okay. So 16, 36, 9, 1, 1, 25. Okay. Now let's find the average of these. So 16 plus 36 plus 9 plus 1 plus 1 plus 25 gives me 88. How would I do average? Divide by 6. Okay, and I get 14.66. However, my numbers are artificially large, so I have to square root it. So we're going to add all these together. But I need to undo all of these, so I take the square root. And I get 3.83. Now, 3.83 is a little bit larger than 3.3. And that will always be the case. But in essence, about $3.80 is owed by every person in one direction or another. All right? That is called the root mean squared. May or may not be important in this book. Okay? So, the standard deviation follows the same model. Oh, come on. So I found out that here the average is 10. Well, the average is not a very good way to describe anything, right? If I said, okay, I'm handing out dollars, on average, everybody in the room is going to have $10. Does that make you excited? You might end up with $100. You might end up with $0. Okay? What if I told you, all right, I graded the tests, and just to make it easy, the average on the test was 79 points, or 79%. Have a good weekend. Would you be satisfied with that? No, because the average does not at all tell me anything about your score. Okay? Well, what if I told you the average of the test was 79, and most people were within 15 points of 79? You would probably feel better about that, knowing, well, I think I did really well, or I think I did average, or I think I did terribly. But if I could give you some plus or minus, you would have a better sense of what's going on. That number is called the standard deviation. The standard deviation tells us how spread out the histogram is. And it's a number that calculates where most people land. Okay? So, how do we find the standard deviation? Well, I need to know how far away was your score from the average. So the person that scored 8, how far away are they from 10? And it would be -2, down 2, right? So this is -2, and then 2, 1, -3, 0, 0, -1, and 3. Okay? Now, if I take the average of those, the positives and the negatives are going to cancel each other, and it's going to give me this really small number that doesn't make much sense. So I need to get rid of the negatives. So I go through and square everything. All right? So that gives me 4, 4, 1, 9, 0, 0, 1, 9. Then I add those up. So 8, 9, 18, 19, 28. So I get 28. What do I do with that? Take the average. 28 divided by 8 is 3.5. And then I square root 3.5. Oh, oops. This one. And I get 1.87. This is called the standard deviation. And the standard deviation roughly translates into average distance from the average. Okay? The average distance from the average. So the SD can be interpreted in a lot of different ways, but if you took how far away everybody was from the average distance from the average is 1.87. Now, that funny square root trick we did actually yields a number that's a little larger. So when I did the true distance from 0, remember how I got 3.33? And when I did the standard deviation calculation, I got 3.89. So the standard deviation is always going to be a little bit higher than the true average. And I asked my stats teachers, why do we use the SD instead of the true average? And it wasn't until I took my very last stats class that she told me. And we'll get there eventually. So this combined with this provides us a lot better information. So I could say the average score on the quiz was 10, and the standard deviation of the quiz was we'll call it 1.9, which means most of the class were between, so if I took 10 plus or minus 1.9, I get 8.1 up to 11.9. Most of the class ended up in that window. Okay? Some were a little bit lower, some were a little bit higher, but most of the people, in fact, it's usually around 2/3 of the people land in that window. Okay, so going back here, that is the standard deviation, 19.2. How is that calculated? It is the average distance from the average. Okay. So the low was Neil Diamond, took somewhere between 60 and 70 seconds. And the high was Alicia Keys and Natalie Cole were somewhere between 150 and 160. All right. So go ahead, answer these. All right, who was shortest? Neil Diamond. Who was longest? Natalie Cole and Alicia Keys. What was the average performance length? 108. Would you consider 120 to be unusually long? So look up here. 120 was pretty common, right? So if you sang the national anthem in 120 seconds, are you above average? Well, the average is 108. So yes, you would be above average. Are you way above average? How do we measure that? How far is too far? Do you remember our broken penny thing that we did? How far is too far? Well, one way to measure is to compare it to the standard deviation. Most of the people are between one standard deviation in either direction. And in this case, the standard deviation is 19. So most of the people land in this window. So 120 is not unusually large. It's large, but not unusually large. If you are outside of one standard deviation, then you are more unusual. Does that make sense? All right. Okay. All right. Can we look at them all? Maybe. Okay, so here is our dot plot of performance length. So now we've color coded it. Red dots are female, gray dots are males. The few plus signs are mixed. So if we only look at the males, the average changes. Or sorry, females. On average, did females take more time or less time than the group as a whole? More time. So 112.8 is bigger than 108, right? What about males? They were less, which makes sense, right? If the females are higher than average, then the males must have been lower than average, okay? And notice the standard deviations are different. The standard deviation for females was only 18.2, and the standard deviation for males is 18.1. Okay, oh, that's all of them. So which performances tend to be longer? Females. Which had more variability? How do we measure variability? So variability is spread. Which one is more spread out? They're pretty close. Does it have wait, what did it ask? Did it ask So the females are slightly more spread out. How do we measure spread? The standard deviation. So on average, the females were 18.2 seconds away from the average. And for males, they were 18.1 seconds away from the average. So I guess technically the answer is female. What did it want? Both. It called them the same. So it's saying that that's close enough. We're just going to call it even. All right. Oh, I did it again. And lastly, suppose that Mary records the ages of people entering McDonald's restaurant near the interstate, while Carlita records the ages of people entering a snack bar on a college campus on the same day. Which is expected to see a larger standard deviation? So we're looking at ages. So we're going to compare ages at McDonald's versus a college snack bar. Which one will have a higher average? Average age. So what age of people go to the college snack bars? 18 to 22, 23. Most people are 18 to 23. What about McDonald's? 1 to 99, right? So if I were to draw the normal curves, if they happen to be normal, which we're assuming they are, so the McDonald's line could go all the way from 0 to 100, right? And maybe it would be slanted a little bit. Maybe it would be like this, right? Maybe there aren't as many old people, or maybe this particular McDonald's doesn't have any young people. It could look like that. But in college, they're pretty much all going to be from 17 to 26, right? So which one is going to have a bigger average? McDonald's, for sure, right? Okay. Which one is going to have a larger spread? McDonald's, why? Well, the middle group, it could cover like 20 years. Whereas here, the middle group might only cover 3 years or 4 years. So average is the middle, but standard deviation is the spread. It's the average distance from the average. All right. Oh, I keep doing that. Oh, hey, we finished. Awesome.